Hello, this is Honors Homework Week 14. Gives us a couple explicit formulas up here and fills us in on a little bit of information. So to find your common difference, we can always take a term and subtract the previous. If we're unable to kind of visually determine. A lot of times we are. This is something you can keep in mind just in case you can't determine what's happening there. Okay. So it says the term is arithmetic. If it is, find the common difference. So you're looking through on these. Am I adding or subtracting the same thing over and over again? If we are, let's say, for example, you look at number 4, like, okay, it looks like I'm decreasing by 10 each time. Right, so we say, hey, this is arithmetic. I've got a common difference of negative 10. Right, some of them will follow a pattern, some of them won't follow a constant pattern, in which case those might not be arithmetic. So be on the lookout for that as a potential thing as well. Otherwise, they're going to have a common difference. All right, so using the first term here, which we know is A1, and our common difference, wants us to name the first 5 terms of the sequence. This is basically just, hey, complete this list of numbers. You know where you start. You know what you change by. Just continue that process. I started at 4. I'm changing by 3. My next one's 7. My next one is 10. All right, continue on with that pattern. All right, so here's us using the explicit formula to jump to specific terms. Right, so it kind of gives you a template here. Then you can use this to model for the remaining questions of this section. It's asking us this: use the different information of our explicit formula to find out what it wants. We want the 112th term. So instead of continuing this list on forever and ever, let's use this explicit formula to our advantage. We know our first term is a 5. All right, now we know the n is equal to 112, right? That's what we want, and for our number of term. I'm looking for my 112th term. All right, and now I just need my common difference. And it looks like from this, I'm increasing by 4 each time. Right? Now, I should have left a blank spot here so that you could also fill this in with a 112, because it's saying that, hey, what the value of my 112th term is going to be whatever all this equals out to. So once we just calculate this as a final number, you'll just have A12, or A112, is equal to, and then whatever number you get from simplifying this component. All right, so using different information, you fill in the known values of your formula, solving for your missing an value. Okay. Now, for these here, it says, for each given explicit formula, rewrite into function notation. This just wants us to take it from the explicit formula. Wants us to change it over so that we are now in function notation. So basically make it a linear equation. Right, and this is just polishing it up. Right, so you can distribute your 6. Right, so then we're left with 5 plus a 6n minus 6 here. Right, then we're combining some like terms. Right, so our 6n doesn't have any like terms, so it comes on down. 5 minus a 6 leaves me with a negative 1. There we are. There's that exact same equation that we have here, except now it's in function notation. All right, so this is getting on to our common ratio. So it says to find a common ratio, you take a term and divide it by the previous term. Right, if the pattern continues, we have a geometric sequence. So this is something to keep in mind. If you ever can't identify what your common ratio is, take a term, divide it by the one before it, and it'll tell you what that is. Okay? So here, let's see, we're going to search for a certain one. Okay? Now this one, let's take a look. We say, okay, well, to get from negative 1 to a 6, I'd have to multiply by a negative 6. And then we can check, does this pattern continue? And it does. Because 6 times negative 6 is a negative 36. Negative 36 times that negative 6 gives me a positive 216. They're alternating back and forth between positive and negatives because we're bringing in another negative. So sometimes they cancel out and turn positive, and it turns negative. And the two cancel out and become positive again. So this is geometric. We have a common ratio of r is equal to a negative 6. Now look out, some of these are not going to be geometric. Be on the lookout to make sure that your pattern does continue throughout. Okay, so here we are for this, something we haven't looked at here in class so far, but we'll be able to cover it here, and also after you see it in the lesson, it should make more sense. So this is being able to find a term using a geometric sequence. All we're doing is plugging in the number we're looking for into n. It's just like on this page here, we were plugging in our information into the explicit arithmetic formula. Now we're plugging in information to our explicit geometric formula, right? And it already has the equations written out, so we're just simply replacing the n here. This is going to have us doing some work with exponents. So to find my first term, I'm looking for 3 raised to the 1 minus 1 power, which is really just a 3 to the 0 power, which is just a 1. All right? Hold on, I might need to make some adjustments here. All right, we're okay. Apologize for that. And so we just continue on doing some, make sure you're keeping up on those order of operations, right? Because to find my second term, I take our equation and plug in 2. Right, so say I wanted to find my second term on 1 down here. I wanted to find my second term for this one. I'd be doing negative 4 times R3 raised to the second term, so 2 minus 1. So I'm going to do negative 4 times a 3 to the first power. 3 to the first power is just a 3. I have to do that part first because it's the exponent before I handle this. So negative 4 times the 3 gives me a negative 12 here. So that's how we do it. We're just plugging in for n to calculate what our term is. Right? And there's other approaches here as well, right? Because we could also think about maybe taking this, multiplying it by our common ratio to find the pattern. Right? So I know that if this is my common ratio, this is my first term, then I'd just be multiplying by 3. Right? Then I can multiply by 3 again and get a 9. And if you wanted to double check this with the formula, we could. To find my third term, it'd be 3 to the third power minus 1, which is just a 3 squared, and 3 squared is equal to 9. So a couple different ways to go about that. All right, so here's just going through. We've seen a little bit of it earlier. Going through for each one. State if it's arithmetic, geometric, or neither. If it's arithmetic, tell me what that common difference is. If it's geometric, tell me what that common ratio is. Right? And then this section down here is just taking your different pieces of information and using your explicit formula. So they're all either going to look like this if they're arithmetic, right, with the appropriate information plugged in for your first term and your common difference, or you'll be looking at a geometric one, so that way we have our A1, then we have our common ratio. That's where you'll be finding that first term and that common ratio. All right, you'll be just filling these out. All right, so that concludes the video for this week's homework, and I will do one of these examples just so you can see what I'm talking about here. If I'm looking, I'll notice, so I'll just do this one here. I see that I'm decreasing by 10. My first term's at 100. Common difference is a negative 10. So I could write out that sequence. It'd be AN is the explicit formula, sorry. Right, that's what it would be if we're arithmetic. If we're geometric for one, like on this one, we are doubling each time. My first term's a 2. My common ratio is also a 2. So it'd be AN is equal to a 2 times the 2 to the n minus 1.